So for extra credit today, I'm going to be doing 5.6 graphing linear inequalities, basically like part 1 because I'm not doing the continued. So basically we're going to be doing it with two variables, like graphing it with two variables that are linear. So it would look like this, like it'd be gx plus cy equals a, or it could be like that, or it can be greater than or equal to, and it could go the other way, like gx plus cy is greater than a. If I said greater than, I meant less than for this one, or it can be less than or greater than or equal to. Then to solve an inequality, it must be like the solution has to be true. Like, you can't have 0 be greater than 7, you can't have that. It has to be like 7 is greater than 0 for the solution to be correct. Because you can't have a solution that makes no sense. It has to be true, and it also can have more than one solution. Like, 8 is bigger than 0, 8 is bigger than 0, so you can have that. And then to figure out, to solve an inequality, to make sure the solution's right, this is how we would do it. So the example says, is the ordered pair a solution to the inequality? You do all the math. They give you the ordered pair. You have 4x plus 2y is greater than or equal to 20. Then you plug this one in with this one, and it would be like 12 plus 8, so this is 4y, and then it's greater than or equal to 20. Then you do 12 plus 8, which equals 20, and then 20 is greater than or equal to 20 is a solution. So say like if this was 4 or something, if x was 4, and then you did 16 plus 8, that would also work because this would be greater than, I think so, 16 plus 8, yeah. So anything works if this is greater than or equal to, but if this is less than, then this wouldn't work. Okay, so then actually graphing it, actually putting it on a plot is how you would do it. You go, it must show all the solutions on the graph. So when you graph it, all the solutions have to be on there. And then if it is like this, if there's no underline to it, then it has to be in a dashed line like this one right here. And if you have this one though, with the underline on it, like less than or equal to or greater than or equal to, then you do it with a solid line like this. For the dashed lines, the points on the line aren't included. When you graph these, you're supposed to shade like the solution side in, so like, and then you like shade it in like that. And because on your point, like this would be your line, right? You don't count that as a solution. Like the points on the dash line aren't in the solution. So the line isn't, but anything shaded in is, but not the line, not the points on the line because it's dashed. So these are not included in the solution. But these are included. The points that are on the solid line are included. So if you have your thing and you have your line, but it's a solid line. I'm sorry, I made the other one not solid, but if you had your solid line and you shade it in, then the points on the solid line count for the solution too. But the ones that aren't, like the dotted line, here, let me do a better example. Yeah, on the dotted line, it doesn't count because it's dotted. So, and then like I said, after that, you shade the side with the solution. So everything shaded has solutions in it. So here is an example of one. So 6, y is less than 6. You put your point and it's going to be horizontal because you don't go up anywhere, you just go to the side. So I'd go to like the side one. It's kind of off, but the side one, blah blah blah, and then you put your point there. And to test it, you can pick any point from this little graph really, and you can test it. And if you test it, it makes sense, and then you shade where that place is. So then you'd shade like this, and that's how you graph linear inequalities with two variables. So I didn't do a word problem because in this one it didn't have a word problem, but if you wanted me to do a word problem again, I could do it. So thank you.